Welcome to Calculus. This is section 8.2, integration by parts. Essential question is, what does ultraviolet blue do? Integration by parts is a technique we use for certain types of integrals, especially when you have products or transcendentals. Transcendentals are like e to the x, or logs, or lins, or any trig functions. So in the cases of these three integrals right here, these would be prime targets for integration by parts. Notice I have an x times ln of x, or an x squared e to x, and e to x times sine of x. Those would take integration by parts. So it's similar to the product rule. Don't write this down, but if you have u times a v, and these are two functions, and their derivatives are both continuous, you sort of like, you break it up. It sort of looks like the product rule right there if you're looking at it, but we actually rewrite this. So here's the formula you can write down. If u and v are functions of x, then an integral of u dv equals u times v minus the integral of v du. So there's the formula we need to write down. And a way to remember this is we got this phrase, ultraviolet voodoo. I got this from some training, and it's stuck in my head now. So ultraviolet, u violet, or this actually right here, ultraviolet voodoo. So the idea here is that u dv is impossible to integrate, but v du you can actually integrate. So this just rearranges those two. So the hard part is you have to actually choose what's your u and what's your dv. So well, here's some guidelines when you're doing this. If you're try to let the dv be the most complicated portion, because you're going to actually integrate it and make it hopefully less complicated. And then the u is going to be whatever's left over. So you can also try letting the u be a portion of what you integrate, and then the dv is just your remaining part. But so dv is usually what's most complicated, and then the u is going to be whatever's left over. And dv is always going to include dx. Another way to think about this is the u is the something you're going to derive, because you're going to go to u prime or u double prime if we do this twice. So the u should eventually go away. So sometimes I look at it like that. And sometimes you guess wrong the first time, and you just have to try it the other way, just like u substitution. So let's do this example. Find the integral of x times e to the x. So I'm going to pick, again, the formula is u ultraviolet minus the integral of voodoo. So the integral of u dv. So you have to pick a u, and your u you're going to derive, and the dv you're going to integrate. So I'm going to pick a u, and I guess I got two options. I can do x or e to the x. So I'm going to pick my u as x, and my dv is going to be e to the x dx. So the neat thing when you do that, actually, no, let's do it this way. So your u, if you're going to derive this, your du is going to be just derivative of x is dx. Your dv is going to be integrating this. If you integrate both sides, you can get your v equals e to the x. We don't write plus c, just say e to the x. So now, because there'll be a plus c at the very end of all of this. So plugging those things in, let's see if it works out. Well, my integral is going to be u times v, so x times e to the x, minus the integral of v, so e to the x du, which is dx. Can you integrate this? You betcha. So it'll be negative e to the x. So my final answer is x e to the x minus e to the x plus c. So you're trying to make something you can integrate easily. If this wasn't easy to integrate, you might switch around your u and v's and du's. So some other suggestions here. So if you have of a format like x to some power times e to some power, generally your u is going to be the x to the power, and the dv is going to involve the e, which is the example we just did. If you had formats where you have a log involved, like x to the n with a log or an arcsine or arctangent, your u is going to be that log or the arctangent, and then your dv is going to be the x to the power. Integrals, when you're mixing like e's and sines or e's and cosines, generally your u is going to be the sine and dv is the e. So general rules. So let's look at this problem. X squared sine of 4x. Okay, so I can try a few things. According to these rules, well, this is when I have sines and stuff, I should let my u be the power. So I'm going to say, okay, my u is the power No, I'm not going to try messing up. I'm going to do it right. U is x squared, and dv equals sine of 4x dx. If I derive the u, I get my du is 2x dx, and dv is going to be the integral of this, which is going to be 1, so v equals 1/4 cosine, or negative cosine of 4x. So I'm going to write that better as negative 1/4 cosine of 4x. All right, so plugging that in, I get a u, x squared times v, times negative 1/4 cosine of 4x, minus the integral of the new things. So I have minus negative 1/4 cosine of 4x times 2x dx. That's looking a little messy there, so let's clean that up. Reducing this 2 and the 4 to 2, and the minuses turn to plus. I'm going to write that as plus the integral. I'm going to put that 2 on the outside and make it a 1/2 times x cosine of 4x dx. Now, here's the thing. You can't do that as is right there, but guess what? You get to do UV substitution again. Woohoo! Yay! So my u, in this case, this is going to be my x, and dv is going to be cosine of 4x. So make sure du a dx. One thing to note here is your dx. Notice this term kind of goes away. It's just a dx for the du. That's the goal here. And your v is going to be positive 1/4 sine of 4x. Plugging that in, and this part's still there, so I'm just going to follow this pattern here. And remember, I got this 1/2 here. So I'm going to go plus 1/2 times the quantity u times v, so x times 1/4 sine of 4x, minus the integral of 1/4 sine of 4x times dx. It's these two. Okay, you can integrate this because it's just sine. So let's make this a little easier, yes, and it's a lot of work. This is one of the bigger problems. So integral of this thing right here is going to be negative 1/4 times negative cosine of 4x times another 1/4. So u substitution. And this is going to be x times 1/4 sine of 4x times that 1/2 on the outside. And I'm going to drop down the other thing too. X squared times negative 1/4 cosine of 4x. Looking messy, and don't forget the plus c by the end. dv equals e to the negative 2x dx. So du going to equal 5 dx. V equals negative 1/2 e to the negative 2x dx. So let's see if we plug that in. That's going to equal 5x times negative 1/2 e to the negative 2x minus the integral of 5 times negative 1/2 e to the negative 2x dx. That works. Cleaning that up, negatives cancel out. I'm going to put a plus 5/2 on the outside, the integral of e to the negative 2x dx. And if you integrate that part, it is going to be 5/2 times negative 1/2 e to the negative 2x plus c, and this drops down as negative 5/2 x e to the negative 2x. And it's an answer. Moving on. Oh, there's nothing there. Oh, there's something. Okay, doing this one, pause the video. Video paused. So like this, it was suggested before, if you have a natural log, make that your u. Make your du, or dv, the x to the 5th, dx. Deriving the du, is going to be 1 over 3x times 3, which can reduces to 1 over x. The v is going to be x to the 6 over 6. So plugging that in, u times v, so natural log of 3x, times, this is v, wait, no, this is v, times x to the 6 over 6, minus the integral of 1 over x, x, times x to the 6 over 6 dx. Boom and boom. What cancels out there is one of the x's. So this can simplify to x to the 5th over 6 dx. And if you do some math on that one, that's going to be x to the 6 minus x to the 6 over 6 times 6 is 36, plus c, and then it's x6 over 6 times natural log of 3x. And there, that one was a little simpler. We're done.